I'm very happy to be speaking here at Service Mesh Con with Anna and about our favorite topic, service meshes, that are, as we've heard, very important. As we all know, running a distributed application can be meshy business, and that's why we're coming here today to talk to you about how to find and fix bugs in your service mesh. So I saw some of you were using service meshes. How many of you have run into bugs in your service mesh? Yeah, okay, well, listen up. So, as you've heard, this is Anna, and she's a systems engineer at Paybase, and she's really good at stacking Kubernetes blocks.
Thank you. And this is Risha. She's a software engineer at Buoyant, and she's the maintainer of Linkerd, and in her spare time, she's looking for her twin. All right, so what are we going to cover today? So the plan is to start talking about mushrooms, and bear with us because it will all make sense. Then we'll look into meshes and specifically Linkerd. Then we'll talk about mysteries, otherwise known as bugs, how to put those mysteries under the microscope, and how to find the issue with the bug and how to solve it. And then we'll showcase our mastery into understanding bugs and hopefully some takeaways from you guys. All right. So my boyfriend's current obsession is mushrooms. And because he simply won't stop talking about them, I've learned a really cool thing about them. So mushrooms form a symbiotic relationship with trees, in which mushrooms get from trees sugar, and trees get from mushrooms nutrients and water. And that made me think how the relationship between users and maintainers should really be like. It should be a give and take relationship both ways, a symbiotic relationship. By the way, this is a bird's nest mushroom, and I think it's really cute. So, back to open source projects. So, as I said, when we are interacting with an open source project in general, whether it's Linkerd or anything else, it shouldn't be a matter of users versus maintainers. It should be a matter of users and maintainers. We're two different groups as part of the same team. And that is important because an open source project grows based on user feedback, user testing, and user contributions. And also some of the open source projects out there are not funded, and some of us users basically get charity work from maintainers. So it's nice to be nice. Effective communication matters, and that can give you opportunities to learn and fix bugs fast and painlessly. So it's beneficial for us, the users, and it's beneficial for the maintainers as well. And we should always remember that behind any computer, there's a person, and we should talk to people online how we would talk to them offline. And with that, Risha will give us an introduction of Linkerd.
Yeah, so what is Linkerd? Linkerd is a service mesh. And what's a service mesh? A service mesh is a dedicated layer that is responsible for service-to-service communication. So it's responsible for the reliable delivery of requests in your application. So imagine your application's running in a pod. When you install Linkerd, what you're doing is adding a bunch of lightweight proxies that run in a sidecar next to your application. And traffic is transparently proxied through Linkerd proxy, and the application's not aware that this is happening. So this addition of the series of proxies next to your application, that's the data plane. You can see the data plane at the bottom of this diagram. At the top is a control plane, which is responsible for interacting with the proxies and also for getting data from them. Because the proxy sits next to your application and it sees all of the traffic going to your application and from your application, it can see a lot of things and measure things like latency, success rate. It can give you really cool things like latency-aware load balancing, retries and timeouts, all sorts of really useful traffic management stuff. And Anna's going to tell you about Paybase and what features Paybase uses.
Thank you. So, Paybase is an API-driven payments platform. And our customers are usually marketplaces, gig sharing economies, cryptocurrencies, or basically any business that has a sophisticated payment flow that a normal payment services provider wouldn't be able to technically handle. And because of that, we're highly regulated, which means that we have to be available pretty much 100% of the time, and we care about monitoring and solving issues really fast. So why did we need Linkerd? Well, over 80% of our platform is built on top of open source projects. So we care about this communication between users and maintainers in general. But also 100% of our services, of our application, runs on top of Kubernetes. And our application is a distributed monolith that is deployed in our cluster following a microservices architecture. So the application is made out of over 50 microservices. And the communication between the services happens via gRPC. And you may or may not know this, but Kubernetes out of the box does not give you gRPC load balancing. In other words, without a solution to this problem, we would not be able to scale our services. So we needed gRPC load balancing to be able to serve more customers. And that's where Linkerd came in place. That's what it's giving us. And to add on top of this, it has nice features like distributed tracing, telemetry, and metrics, and so on. So at the beginning of the year, I've started configuring Linkerd into our cluster. And as I was expecting, we have had all sorts of issues. This is because Linkerd is quite a new project. It's very mature, but it's new. And we have a very, very complex application. We do work in payments, after all. So to give you an example of one of the bugs we were seeing, you can see on the left-hand side, the area that's highlighted. Those are headers that our application was expecting to get. And on the right-hand side, you can see how those headers got mutated after they went through the Linkerd proxy. So to take that back to what William said about plumbing, you could see this as our application was expecting clean water, and instead it got rusted water, and it didn't want to deal with it. And that's how we're getting 502 errors. To get to the point where we figured out that this was the exact issue, it was quite a journey. So I want to provide you with a framework for troubleshooting that I came up with that might help you as well. And before we do that, I want to quote Brian Redmond, who said, "Be warned that being an expert is more than understanding how a system is supposed to work. Expertise is gained by investigating why a system doesn't work." In other words, failure is absolutely desired so we can learn and grow as software engineers and as companies that better serve customers. And being able to troubleshoot requires at least a very basic knowledge of the system you're troubleshooting. So try to learn that if you don't have that knowledge. And Google, in their site reliability engineering book, came up with this super cute diagram that shows all of the different steps of how you'd go about troubleshooting. And they're defining the problem report as the source of your issue, so whether you're paged, or you're configuring something and you got an error, or a customer complained about unavailability. The next step would be triage, so deciding what you're going to do with your issue, whether you decide this is something that you're going to skip altogether, or this is something that is very important and you need to tackle straight away. And the next few steps have to do with examining, trying different things, and trying to cure your system. As I said, this is really cute, but this is not how it works in real life. In real life, there's a lot of back and forth and so on, and it's much more messier. So I've created a decision tree of what to do when you get an error in your service mesh. So there's a lot of questions that you would ask yourself and a lot of things that you need to try. right. So you got an error, and the first thing you would ask yourself is, are you sure this is service mesh related? If the answer is no, then the next thing you should do is try your application without the service mesh. So unmesh the whole thing, try again what you're trying, and see if you're lucky. If you weren't lucky, aka if the error still persists, then it seems like you have an application error. So forget about the service mesh, go and fix your application, try everything again. However, if the test you're trying to do was successful when you unmeshed the application, then it's quite safe to assume that you're having a service mesh related issue. And if you do, the next thing you should ask yourself is, could this be a configuration error? If it is, if you think it is, you should double check all of the configuration and docs and see if you missed anything. And if you did miss anything, then you are in a super, super lucky position in which you've already found your fix and you're done. However, if you've double-checked the configuration and you're still getting the same error, then the next question you ask yourself is anyone else having the same issue? And this is where you go to your communication channels, to Google, GitHub, Slack, and try to find out more information about the particular error you're getting. And if the answer is yes, someone else is having this issue, then the next question is there a fix available? If there isn't, can you fix it? And if the answer is yes, then this is your chance to be a superhero and give back to the open source project. So open a PR and save the day. However, if the answer is no, you cannot fix this, then what you want to do is comment on the issue or the bug, add your specific findings, and this will help the project to better triage issues and provide additional context that they might be missing. If there is a fix available, then you're in luck. Go ahead, fix your issue, and move on. However, if there is no duplicate of your issue, then another thing that I like to try is asking myself, have you tried a different service mesh version? Sometimes you have a bug that has been introduced from one version to another, or was fixed in a newer version. If you've tried a different service mesh version and you're still having issues, then again, can you fix it? If you can, please open a PR. If you cannot, this is the time when you file a brand new bug with all of the details that you have. And I've also mentioned that it's important to have knowledge of your system and how it works. So I've created this diagram. It's very simplified. But if I was to add all of our services, nobody would understand it, not even myself. So this is a system in GCP running on Kubernetes only, using nginx as an ingress controller. And the way it works is an end user request sends a request to your domain. That request gets routed to a Google front-end firewall, which then gets routed to Google load balancer, a layer 3 load balancer. And if it passes all through here, then the next step is getting into your ingress controller into your nodes. And this happens at random. Any ingress controller can serve that request. And it's worth mentioning that Linkerd also supports traffic and other ingress controllers. But this is what we use. So the encrypted request, the HTTPS request that came into nginx gets reviewed. And if it passes forward, here's where the encrypted traffic stops, and it is passed forward as HTTPS traffic to one of your services. And then from here, the service will take it and pass it forward to whatever other service it needs to talk to as gRPC. So this was important to know when troubleshooting. And now let me show you the much more complex version of this diagram that contains the Linkerd proxy and how it's meshed. So again, your end user request makes the request to your domain. It goes through Google frontend to the load balancer. And then instead of being hit directly into the nginx container of your nginx, this time it's getting routed into the sidecar container of nginx, the Linkerd proxy. And the Linkerd proxy takes that request, reviews it, and passes it onto nginx as TCP encrypted traffic. nginx, again, reviews it and responds back with decrypted HTTP to the same Linkerd proxy. Then from here, the Linkerd proxy passes it on, this time as secure gRPC, which is what the application is using, into the Linkerd proxy of the service that it's expected to go. And here, the communication between the service and the Linkerd proxy happens via gRPC. Again, you get a response, and that response goes into the next service. And this whole bit was important for us because our request was going through multiple services, and we could see that the first few services it was passing through without a problem, and we would hit the issue later on. So being able to have this view was quite important. The next thing I've mentioned was filing an issue, and my recommendation when it comes to filing an issue is a bug report on GitHub always has a template of the things that they expect you to provide. So please do provide that, or at least as much as you can, because the maintainers will take you more seriously. It will provide additional detail. And yeah, it helps everyone, basically. It will make the issue resolved faster. When you do file a bug, don't assume that people know your system. So try to have a brief explanation of that. And you should always include everything you've tried. So whether you've tried different Linkerd versions, whether you've tried different dependencies, include that. And this is universal advice for any time you use an open source project. And from here on, Risha will tell us more things about bugs and triages and how to fix them.
So triaging. In the Linkerd project, we get a lot of bug reports, so thank you for filing those. But at the end of the day, we have to work on something, so we need to sit down and figure out what to work on and what to prioritize. How do we do that? There's two main things, one of which is reproducibility. So first, is the bug clearly filed, and do we understand what the bug is about? And then also, do we have a repro case? And ideally, we would have a small repro case because it's really difficult for us to reproduce everyone's production configurations on our side if we don't have access to your entire infrastructure. The next thing is impact. How severe is the bug and how many people are experiencing it? And what's helpful here is if people are commenting or thumbs-upping on an existing issue instead of filing duplicates, because that will give us one place that we can see, oh, a lot of people are experiencing this bug, maybe we should prioritize it. So yeah, we've received a good bug report, and now we need to go figure out where it is. And as Anna mentioned, architectures can be complex, so the bug could be in a number of places. It could be in Anna's application, in Anna's application's dependencies, in the Linkerd control plane, which is written in Go, in the Go dependencies, in the proxy, which is written in Rust, in the Rust dependencies. It could be in Kubernetes. It could even be in the Linux kernel, and we have encountered that. So that's a lot of places. So, okay, we received Anna's bug report. Again, let's try to isolate where the bug is happening. So the initial report had application logs and proxy logs, and we were seeing protocol errors. But that wasn't enough to tell us exactly where it was. So we went back on the ticket and asked for more input, which was the output of Linkerd tap. And Linkerd tap is a useful diagnostic tool that allows you to see what requests are flowing through a proxy at a particular time. Again, that wasn't as helpful as we wanted it to be. So we went a level deeper into the TCP dump. And here, observing the TCP packets, we started to see some stuff. We saw that headers were being split across multiple frames, which was unusual, and we hadn't seen that before. Okay, wait, headers, frames. If you don't understand what that means, let's back up a second and give you some background info so you can understand this bug. There's two things you need to understand, one of which is how Linkerd uses HTTP2, and another is just a little background on how HTTP2 works. And I will be saying H2 instead of HTTP2 because HTTP2 takes a long time to say. Okay, so first, H2 in Linkerd. Remember this diagram where you have the Linkerd data plane. So when service A wants to talk to service B, in a meshed application, instead of service A directly talking to service B, it goes service A's proxy, service B's proxy, and then to service B. So what you need to know here is that the communication between service A's proxy and service B's proxy, as Anna mentioned, is in gRPC, which uses H2. Okay, the second thing, a little bit of background on H2. One of the really cool features of H2 is multiplexing, so sending multiple requests and responses kind of at the same time over a single TCP connection. How does it do that? Well, each request or response message is broken down into units called frames, and the request is sent as a stream of frames that are interleaved with other frames, and that's how the multiplexing goes. Each frame has a stream ID that tells us what request or response it's a part of, and a frame type that tells us what type of data is being transmitted in the frame. Here you can see two frame types, a data frame and a headers frame. The headers frame is used to transmit headers. Surprise, surprise. If there's too many headers to fit in a single frame, you can send another frame type called a continuation frame, and you can send more headers in that. The next thing I want to talk about briefly is header compression. So H2 allows you to transmit less data by compressing headers. It uses a compression format called HPAC, and one of the things HPAC does is it has the client and the server maintain a table of headers, and instead of sending the full header, it sends the index of that header in the table, and that allows you to transmit less data. And this table is actually two tables, a static table of commonly used HTTP headers, and a dynamic table that's updated based on the headers you see in the connection. The dynamic table is of a fixed size, and if there's too many headers, it might evict some old headers. Okay, with that, we have enough information to go back and understand this bug. So remember, Anna's payload is a large payload. It might be split into multiple frames. It might have a continuation frame. And also notice that there's repeated headers. And in fact, that was bug number one. So part of the reason this was so complex to diagnose was that there were multiple bugs in play, but eventually we found them. So the bug was that our code was panicking when a continuation frame had a header that was repeated. Bug number two was that we were looking for headers in an index that had been evicted previously. And there you have it. We found the bugs, and we fixed the bugs, and the user was happy. So that is good. But our work didn't stop there. So we're continually using bug reports and triages to improve the diagnostic tooling in Linkerd, because it's important for you to be able to use Linkerd to diagnose bugs in your application, but it's also important to have good tooling to figure out if the bug is in the mesh itself. So some of the things that Linkerd has is a diagnostic sidecar container that has a bunch of cool tools that you can deploy the sidecar, and then you'll have all these tools available like tshark, IP route, that kind of thing. We've also been improving Linkerd taps. You can see more things when you run Linkerd tap. And another thing is improving tracing in the underlying Rust libraries so that when a bug in our H2 implementation happens, we can easily figure that out. Okay, Anna's going to tell you about some of these useful commands for troubleshooting.
Thank you. So from our side, it was quite hard to troubleshoot, so wanted to share with you some of those commands that were useful to get additional context. So first of all, increasing the log level. So by default, Linkerd proxy, Linkerd gets installed with info and warning levels. So you can increase that log level using these commands here. Another thing we found useful was being able to skip inbound and outbound ports to see how our application would behave when the Linkerd proxy would skip certain ports. But also, this is very useful if you're doing whitelisting in your application and you need Linkerd proxy to pass on the IP address, the external IP address where a request is coming from for your application. Enabling Linkerd debug container was really useful. So there's an option to add an additional sidecar container to your application. And that debug container gives you the ability to run TCP dump, tshark, and more. And in order to run the TCP dump, you want to do that if you need to analyze the raw packet. So you have the command here. Listening to traffic stream for like live traffic stream for a resource using Linkerd tap was really useful. And another command that was useful specifically in the early days of Linkerd when we were seeing some additional latency when the application was meshed was the kubectl top pod. So that could give us the resource consumption of each one of the pods, and we were able to compare them. And with that, we want to bring everything home. And to summarize, there was more than a bug. As I said, we always expected it. For us at Paybase, things are never quite straightforward because of complexity. But all of the bugs got fixed fairly quick because we took the time to provide detailed bug reports. And something that I've seen in other bugs is that a lot of engineers say, we're having this issue, and the Linkerd guys come back and say, hey, we think we fixed your issue. Can you try this version? And the answer is, maybe I can try next week because my manager, I need approval, something like that. So for us, we were able to test with Linkerd, without Linkerd. We were able to test different versions and different types of setups. So if you're a manager out there, make sure you let your engineers test many things. We used all of the log suggestions in the issue template when we filed the template. And we did other things like looking through code, looking through other bugs, looking to different dependencies, and so on. And all of those were really useful, as well as the effective communication between us.
Yeah, so it was really great to work with Anna throughout this experience because Paybase was really responsive and gave us really detailed bug reports, and also because being nice is nice and they're really nice people. So I hope that you have learned something today and that you go forth and maintain a symbiotic relationship between users and open source maintainers. So thank you. And the slides are available there.